we're on 13.3 today. Conjectures and Counterexamples on page 356. Two different objectives here. We're going to verify a conjecture or provide a counterexample. And then we're going to form a conjecture and prove that it is false or demonstrate it's true by testing various different cases. Okay, oh, and then there's Parker. Woo, surprise, surprise. All right, what is a conjecture? It's a statement that appears to be true, but that has not yet formally been proven to be true yet. A counterexample is exactly what it sounds like. It's a case that proves that the conjecture is false. Only one counterexample is needed to prove a conjecture is false. Just FYI there. All right, so first conjecture, the square of a number is always greater than the other number. Okay, so let's see if this conjecture is true or false by testing a couple different cases. So let's say that n equals a number. Let's do that. Okay. So let's do this. Let's do n equals 2. And then 2 squared is going to equal 4. So here, this square is bigger than the original number. All right. Let's do greater than 1. Okay. So we're going to do this. Let's do 3 squared. N equals, oopsie. Do n equals 3, and then 3 squared. So in this case, 9 is greater than 3. All right. Let's do a number that is less than 0. Okay. So let's do negative 10 for equals n, and then negative 10 squared is going to be 100. So that's also true. Okay. All right. Well, how about 0? 0 squared equals 0. Okay. Alrighty. Okay, not true. How about fractions? Alright, let's do this. Let's do 1/3 squared. I'm going to erase some of these. Let's do this. Let's do n equals 1/3. Alrighty. So 1/3 squared is going to equal 1/6. So this is the counterexample that would prove this conjecture to be false, because our original number 1/3 is actually greater than 1/6. Okay? So not every squared number is greater than its original number. Okay? So this would be your counterexample saying that it is incorrect. You only need one counterexample to prove that a conjecture is false. Alright, the sum of two odd numbers is always an odd number. So, start off with 1 plus 1. Which equals 2. So immediately we have just totally disproven this conjecture, because these two odd numbers added together equal an even number. So this would be false. Again, you only need one counterexample. The last example we're going to do is all prime numbers are odd. Okay, so you think about all prime, and at first you're probably thinking, yes, absolutely, all prime numbers are odd. But in fact, it's actually incorrect, and this is how we're going to find it. I'm going to just start listing all of my odd numbers. Or not odd, I'm sorry, prime numbers. Woo, prime numbers. 1, 2, 3, 5, 7, 9, 11. I'm going to stop here because I've already found that I have an even number that's prime. Okay? 2 is not odd. So this right here, not all prime numbers are odd. Okay? Alrighty. So when you start working on this kind of topic, you're going to find out that it might be easy to disprove a conjecture, and it might be pretty difficult, if not impossible, to prove that a conjecture is true. So just to kind of keep in the back of your mind, okay, the importance of establishing the conjecture for all cases. Okay? Not all conjectures can be shown to be true or false. So you just have to kind of keep that in the back of your mind. It's not always black and white. Okay? I want you to look at the green table, not triangle. Oh, we just did that one. Sorry. Look at the green rectangle table on page 357. Okay, it says a multiple of 6 is always a multiple of 3. We talked about this today earlier in class. So you can make a table like you see right there on that page, or you could break down 6. 6 breaks down into 2 times 3. since 3 is a factor of 6, everything that 6 can go into evenly is also going to be a multiple of 3. So how about, let's do this one. Let's do a multiple of 42 is always a multiple of 3. Well, when you break down 42, oh, not 47. 42 that breaks down into 6 times 7 or 2 times 3. So if these are all numbers or multiples, could go into whatever multiple of 42 because they are factors of 42. Okay? I know this seems kind of weird and a little crazy, but we will get there. So that's it for the video. Pretty short one today. Make sure to finish all these notes, and I will see you next time in class. Bye, guys.